Okay, so today I'm going to give a short explanation on how to solve second order non-homogeneous differential equations with constant coefficients. And this is called the method of undetermined coefficients. Um, the solution form is y is equal to y of c plus y of p. Y of c is the complementary solution and y of p is the particular solution. The complementary solution is just the homogeneous solution. Okay, so the first step is you want to find the homogeneous solution y of c of your equation. Um, First, you have to find the roots. Distinct roots of the form y of c is equal to c1e r1t plus c2e r2t. Repeated roots is y of c is equal to c1e to the r1t plus c2t e r2t. Complex roots has the form y of c is equal to e alpha t times c1 cosine beta t plus c2 sine beta t. The second step is to find the particular solution, y of p. So this is the equation that you'll have second order because it's y double prime, and you have g of t, and g of t can be a polynomial, exponential, or sine or cosine function. We can also find the solution to y of p if there's a combination of these three different types of functions. Each one of those different types of functions has its own general form. Polynomial, say you have t to the fourth, the general form of y of p is a times t to the fourth plus bt cubed, and so on. And this scales with how large this exponent is right here. So if this was t cubed, you'd start with a t cubed plus bt squared. Exponential is pretty simple. If you have e to the t, y of p is equal to a e to the t. If you have a sine cosine function, your y of p is equal to a sine t plus b cosine t. It's really important that y of p or yp and yc are linearly independent, and I'll show an example of when they're not. So here we have y double prime minus 2y prime plus y is equal to e to the t. And first you get your homogeneous solution, and that's y of c. You just factor this, and you get c1 e to the t plus c2 t e to the negative t. And since it's an exponential, your yp is equal to a e to the t. But that's a problem because that means that c1 e to the t and a e to the t are linearly dependent. So what you do in this case is you multiply yp by t. So you'd have at e to the t, and then that'll solve that problem. And you can just keep on multiplying by t until they're linearly independent. Here's an example. This is a polynomial example. You have y double prime minus 7y prime plus 12y is equal to 4t plus 6. First, you solve the homogeneous version of this differential equation. So you factor it. That gives you your y of c is equal to c1 e to 3t plus c2 e to the 4t. And your y of p, your particular solution, has the form of y of p is equal to at plus b. And you just differentiate this twice. So y of p prime is equal to a, y of p double prime is equal to 0. And you plug in these two, or all three of these, into your original equation. And that gives you negative 7a plus 12 times at plus b is equal to 4t plus 6. And now you just solve for the coefficients. And since 12at is the only part in this left-hand side that has a t in it, 12a has to be equal to 4t, or 12a has to be equal to 4, so a is equal to 1/3. And you plug in a for your a in this. So since your only two things left in this left-hand side is negative 7a and 12b, those two have to be equal to 6. So you plug in a into this, and that gives you b is equal to 25 over 36. And then you plug in your a and b back into your y of p right here, and that gives you y of p. And you combine y of c and y of p, and that gives you your solution. So that's it. Thank you.